today we will be looking at how do we find the volume of a composite solid. So when we did composites before, we were looking at composite shapes and area. Composite means things that are put together that are more than one thing. So for example, an ice cream cone. An ice cream cone is made of a cone, and it's also made of a hemisphere or a half circle. That is a composite solid. It's solid because it is three-dimensional. So you can fill that cone with ice cream plus the dome part on the top. So composite solids are, these are solids that are made up of, so let's write out our composite. A composite solid is a solid or a figure or a 3D object that is made of two or more dimensional figures or solids. Figures. They use the word figures, so let's use the word figures. Okay, so it is a solid that is made of two or more three-dimensional figures. So it's a solid that is made of two or more. Okay? All right. Our next word that we're going to look at is the word hemisphere. If you think about social studies, you think about northern hemisphere or southern hemisphere. You have a shape of the world, right? So you have a globe, and when you look at the globe, you've got the northern hemisphere. Well, it's cut by the center, right? Or the, goodness, what is that word? The center of the world, right? You've got the northern and then the southern, the equator. Ha! The equator. So you're cut by the equator. It's the top versus the bottom of the world. Okay, so hemisphere is our word. Hemisphere. So notice you have the word sphere in there and hemi or half of the sphere. So a hemisphere is 1/2 of a sphere. A lot of composite solids happen to use a hemisphere or half of a sphere. All right, let's just go ahead and draw what that would look like. Okay, so you've just got that top half of the sphere. All right. Let's talk about a silo. So let's look at a silo. A silo is a place where farmers keep extra hay or wheat or corn or things like that. And you also can think of like a water tower. Both of these things have a shape that is a three-dimensional figure. It is a solid of, let me see how I'm going to draw this. Okay, it is a cylinder, so you've got your cylinder part. But then on the top, where you would typically have that little circle right there on the top, instead what you have is a dome or a hemisphere. Okay, so now we're going to have this like dotted line that goes through the top. That looks like a really angry character of some kind. Okay, on your silo, you have two pieces. So let me see if I can separate this better. You have a semicircle, which is right here with your dotted lines. And then you also have the cylinder part. Okay, so what we're going to do is we're going to look at finding both of these separately, and then we're going to join them together just like we did before. So you've got your cylinder, and then on the top you have your hemisphere or semicircle. So let's start with the cylinder first, because the cylinder will help us go into the semicircle. So let's figure this out. The first part of this says that the dimensions are 40 feet, and it has a radius. So R equals 12 feet. So the height here is 40, and the radius is 12. So we're going to break this into two different parts because there are two shapes here, two solids. So two solids, which equals hemisphere. And then the other solid is the cylinder. All right, so let's go ahead and solve for the cylinder first. So the cylinder I did in blue, so I'm going to go ahead and also do it in blue again. So our cylinder, we know that to find a cylinder, we're going to use pi r squared times the height, right? So any cylinder, we're going to use the base times the height. So the area of the base times the height, and that's how we get the volume. All right, so instead of pi, we're going to use 3.14. R squared, our R is 12. So we're going to use 12 squared, and then our height is 40. 12 times 12 is 144 times 40 times 3.14. Okay, so let's look at 3.14. Where's my little calculator here? There we go. All right, so we are going to do 3.14 times 144, and that gives us 452.16. We're going to multiply that by 40. So we're going to times that by 40. And that's going to give us a total of 18,086.4 feet cubed. Okay, so now our job is going to be to find the hemisphere. So when we found the area of a circle, we found that we needed to, or the volume of a circle, or I mean a sphere. Oh my gosh, missing letter. Volume of a sphere, we did 4 over 3 times 3.14 times r cubed. Okay, so our r is 12, so we're going to do 12 cubed times 3.14 times 4 over 3. And again, all of these are going to go over 1 so that we can just multiply straight across. So let's do 12 to the third power. When we do 12 to the third power, we know that 12 times 12 is 144, and then we're going to multiply that by another 12. And that is going to give us 1728 over 1. All right, now we're just going to multiply straight across, and then we're going to divide by 3, and that's going to give us a sphere. So 4 times 3.14, we should have that memorized by now, times 1728. That gives us 21,703.68, and that's going to go over 3. So we want to divide this by 3. So we get a volume of a sphere, that is 7234.56. However, we have a half. So our job now, I'm going to move this up, is to divide this by 2 because we're looking only at the northern hemisphere. So think of it as the northern hemisphere of the solid there. So divide that in half, and that gives us 617.28. Okay, and this again is still feet and it's still cubed. Now we have to add these two parts together. So we're going to combine these together with a giant plus sign. Add them together because it is the bottom of the solid plus the top of the solid. So when I add this to 18,086.4, I'm going to get a grand total. That is a lot of solid there. So I'm going to get a grand total of, total volume is 21,703.68 feet cubed. If we were looking at this, we could also just round this to roughly 22,000 square feet. I mean, cubed feet cubed for volume. Okay, so that is one composite solid. You have a hemisphere, you also have a sphere, and so that is, yeah, that's that. Okay, let's go ahead and look now at an ice cream cone. Okay, so let's say that we have an ice cream cone. So I'm going to go to example B. Example B, I have an ice cream cone that happens to look something like that. There's my cone, and then I have my ice cream on top. Okay, so I have my ice cream on top. The radius of this is 4 inches, and the height equals 12 inches. So our job now is to find these two shapes. Okay, so we're going to find these two shapes. First, let's start by looking at, we can either start with the cone or we can start with the sphere. I want to start with the cone. So we have two parts. We're going to look at the cone first. So here's the cone. And then after that, we will look at the top part of our ice cream, which is bubblegum ice cream, apparently, is the pink part. Okay, so let's look at the cone first. So we're going to look at the cone. And to find the volume of a cone, we do pi r squared times the height, and then we're going to divide it by 3. So for pi, we use 3.14. R, we're having 4, so times r squared, it's going to be 4 squared, and the height is 12 inches. We're going to multiply all this and then divide by 3 at the end. So, well, yeah. So 3.14 times 4 times 4 is 16. So we have 16 times 3.14, and that gives us 50.24, times 12, and that gives us a total of 602.88. But because it's a cone, we have to divide it by 3, and that's going to give us a total of 200.96 inches cubed. Okay, so this whole area here, this whole orange cone part, is 200.96. Now we need to find the hemisphere. So we're going to look at the hemisphere, or half of a sphere, which is in pink. So this part here. Again, we know that we're doing 4 over 3 times 3.14 times r cubed. R is 4, so 4 cubed times 3.14 times 4 over 3. Put these over 1. All right, so what is 4 cubed? Well, 4 times 4 is 16, times another 4 gives us 64. So 64 times 3.14 times 4, all divided by 3 again. Okay, because 3 times 1 is 3. So we're going to do 4 times 3.14 is 12.56 times 64 is 803.84. Divide that by 3 now. Okay. So our cone is, we're just going to round that number to 0.95. So 267, that looks like a Z, 0.95 inches cubed. Okay, now you can't have ice cream without the cone. I mean, you can, but that's just not any fun. And eating a cone without the ice cream, well, that's just really bland. So we're going to put these two together and we're going to have an ice cream cone. Okay, so you can't have ice cream without the ice cream. I mean, you can't have an ice cream cone without the ice cream and the cone. So to put them together, we're just going to add the two parts. So we will add that plus 200.96, and that is going to give us 468.91. Okay, so we are going to add those together, and that gives us a grand total for volume of 468.91. And that is inches cubed. Okay, it is your turn for a try it. So go ahead and get yourself ready for that. Our try it today. Let me get you a try it. You have a silo, and on your silo, you have your cylinder part there, and then you have your dome part there. This is a little silo. Okay, so two parts. The radius of the silo is 9 feet. So from here to here is the radius equals 9 feet. And then the cylinder part is 48 feet. So from here to here is going to be 48 feet. All right, go ahead and hit pause right now so you don't hear me solving this. And then when you're ready, come on back and start to check your work. Okay, so we're going to have two parts to this again. Again, we're going to have the bottom, which is a cylinder, and then the top of the silo, which is a sphere, or half of a sphere. Oh my goodness, you guys. I forgot to cut this in half. Darn it. I knew I was going to forget that. We needed to divide this by 2. I am so sorry. We needed to divide that by 2 because it's half of a cone. So we need to start adding divide by 2 for the hemisphere up there so we don't forget to do it. So this answer is not correct. I'm so sorry. Okay, so we had 267.95, and we had to cut that in half. I don't know why, I was just so excited about all the ice cream. So the total ice cream then is 133.98 inches cubed. We're going to add that to this, not this answer. So your total volume then, 200.96 plus this, plus 200.96 is going to give you 334.94. I don't know why I keep forgetting things. 94 inches cubed. This is why you have to go back and double check your work. So sorry about that, and it's super messy. Okay, I promise we won't forget to divide by half on this one. Let's start with the dome so that we don't forget. So we're going to start with our dome shape. To find the dome shape, we have a radius of 9 feet. So we're going to do 4 over 3 times 3.14 times r cubed. And again, we have to divide all of that by 2 at the end. So we're going to just go through this and put 9 feet in. 9 cubed times, we know that 4 times 3.14 every single time has been 12.56. So let's just go ahead and do that. And we're going to put this as we need to divide by 3. And then again at the end, we're going to divide by 2. Okay, so 9 cubed. Where did my... There it is. Woo! Losing it. Okay, 9 times 9 is 81. Times another 9 is 729. So this equals 729 times 12.56. So we're going to multiply times 12.56, and that gives us 9156.24. And then divide that by 3. Divided by 3. And that gives us 3052.08. But again, it's not a sphere, it's a dome. It's half of it, so we need to cut that in half. So we're going to cut that in half, divide by 2. And that gives us 1,526.04 feet cubed. Okay, that is for the dome. That's the dome shape. Now we're going to worry about the cylinder. So the cylinder, we have pi r squared times 48. R was 9 squared times 48. 9 squared is 81. All right, so we're going to do 81 times 3.14 times 48. That gives us 12,208.32. Now we have to add, oh my gosh, we have to add this and this together. So that plus 1,526.04. And we get a total of 13,734.36 feet cubed. So that is the volume of the cylinder. All right, go ahead now and answer your essential question. How do we find the volume of composite solids? And then put your level of understanding out to the side. When you're finished, you can come on back to the Google Meet and ask for help, or you can go to Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.